In this titration problem, we are told that we have 75 milliliters with an unknown concentration of a hydrochloric acid solution that is being titrated to the equivalence point with 27.3 milliliters of 0.157 molar, which is the concentration, of calcium hydroxide. We are asked to find the concentration of hydrochloric acid in the original solution. So let's draw a picture to understand what the problem is asking us. We have two containers. In the first container, we know that we have a 75 milliliter solution of hydrochloric acid. So we know that we have 75 milliliters, and we have an unknown concentration. This is what we're trying to find. Of hydrochloric acid, which consists of H plus and Cl minus ions floating in the solution. In the second container, we have calcium hydroxide, and we know we have 27.3 milliliters for the volume and a concentration of 0.157 molar. Calcium hydroxide is consisting of calcium ion, which is has a charge of 2+, and two hydroxide ions, which are OH-. Since we're titrating the hydrochloric acid solution, we're pouring this solution into this container. So let's write a balanced reaction to relate the two reactants to the products. We know we have hydrochloric acid, which is aqueous because we have ions floating in the water, plus calcium hydroxide, which is also aqueous because the ions are floating in the solution, which yields HOH, which is H2O, which is a liquid, plus calcium chloride. But there's a 2 subscript on the Cl because the calcium has a 2+ charge and the Cl has a -1. So by crossing the charges, the 2 will actually be a subscript on the Cl. So now we need to balance this equation using stoichiometry. So we know that on this side we have 2 Cl and on this side we have 1. So we need to put a 2 in front of the HCl. And now on the reactant side of the equation, we know that we have 2 hydrogen and 2 more hydrogen, which equals 4 hydrogen. So on this side, we need to multiply this by 2 so we can have 4 hydrogen. And now we have 2 oxygen, 1 calcium on this side, and 1 calcium on this side. So this reaction is completely balanced. So now we need to figure out the original concentration of hydrochloric acid. So we all know the formula that concentration equals moles divided by volume in liters. So we're going to use this formula to help us figure out the original concentration of HCl. We are given the volume and the concentration of calcium hydroxide, so we can use this equation to relate the two and then convert moles of calcium hydroxide into moles of hydrochloric acid using the stoichiometry from the balanced reaction. So we need to start by making this equation into an equation that will relate volume and concentration. So we will just multiply the volume and get the equation volume times concentration equals moles. So we're going to use this equation and then relate the moles of calcium hydroxide to the moles of hydrochloric acid. So since the volume has to be in liters, we need to convert 75 milliliters and 27.3 milliliters into liters. We do that by dividing them each by 1,000. So this volume is actually going to be equal to 0.075 liters, and this volume is actually going to be equal to 0.0273 liters. So those are the values that we're going to be using in the problem. So we start with volume times concentration from calcium hydroxide, which is going to be 0.0273 liters times 0.157 molar. This is going to give us moles of calcium hydroxide. We're going to multiply that and use the stoichiometry from the balanced reaction, which will allow us to convert the moles of calcium hydroxide to moles of hydrochloric acid. Since this is on the top, we're going to need to put moles of calcium hydroxide on the bottom so the moles will cancel. And since in the equation there's an implied 1 as the coefficient, we will use 1 mole calcium hydroxide, 2 moles of hydrochloric acid. This will give us the moles of hydrochloric acid because the moles of calcium hydroxide would cancel. And this answer is 0.0085722 moles. Now, knowing this original equation over here, we will divide the moles of hydrochloric acid by the original volume that we are given for hydrochloric acid, which is 0.075 liters. And this will give us the concentration of hydrochloric acid, which is 0.114296 molar. There are some common mistakes that could be made in this problem, including not balancing this reaction correctly or setting up the stoichiometry wrong in the final problem by mixing up putting hydrochloric acid on the bottom and calcium hydroxide on the top, which would not be correct because the moles would not cancel. And another common mistake would be not converting milliliters to liters in the original solutions. So all of those mistakes could lead you to the wrong answer, but this is the correct answer, and this is how you do a titration problem.